Okay, so let's revisit this idea of isolation. When it comes to protection and security, isolation is actually your friend. Okay, that means, I am isolated from somebody else, then they can't do anything bad to me. Untrusted user code has to be isolated from the system code. Okay, we talked about trusted system code, tamper-proofness that we're talking about. You shouldn't be able to alter it, and the only way you can go in the operating system is through system calls that are defined by the operating system and so on. So how are we going to achieve this isolation of user code? The reason I want you to think about this is, what does a processor do? It says fetch the next instruction. To execute it, you need some operands that are somewhere in memory. You fetch those, you execute the instruction, and you keep doing that forever. Well, I'm let's say executing some user code. Why can't I say the next instruction I want to switch to somewhere in the operating system, or the next data item I want to bring is a data structure that resides in the operating system? If you tried to do that, we said you wouldn't be able to do it because we have this execution mode we're talking about and things like that. So we're going to use that hardware support to achieve or accomplish this isolation, separation of user code from the operating system code. So let's see how we actually going to be able to do that. Well, the way to do that is, again, I said we're going to rely on the hardware to protect memory. So remember isolation, I said the way if using or executing in user mode or executing user code, and at that point if the hardware can protect memory where the operating system is. What does memory protection mean? We said if the processor generates read-write requests or load store requests or executes those instructions to fetch the next instruction or fetch the data that it's going to operate on, it's going to generate an address where it wants to do a read or write. Well, the hardware says you're not allowed to access that part of the memory. Okay, hardware support is saying this is part of memory that belongs to the operating system. Okay, that's what the operating system code and data is. If you're running in user mode, you're not allowed to generate an address and be able to complete a read or write in a memory location that belongs to the operating system. So hardware support, memory protection essentially says if the processor happens to generate an address that is in the operating system, the hardware support we have for memory protection is going to stop that memory access from completing. Okay? Although it's generating an address and it's a memory location, the hardware that potentially can do a read or write there, but it currently knows that it's user code, and user code directly can't access the data that or information that we have in the operating system part. So the hardware is going to essentially stop that access from proceeding. So hardware is going to sort of keep you contained in your space. And we'll get to that. It's not just OS user, but it's also across different user processes. But it's going to contain you within the area of memory that belongs to you. And if you try to touch something else, which you can, it's going to stop you from doing that. And the hardware is going to do that. How this hardware support we have for memory protection is actually going to do that.